Hello YouTube viewers, welcome to my channel Science to Technology. In today's show, Rocket Monday, we're gonna talk about United Launch Alliance. So let's dive right into it. Well, first we have to understand what exactly we are talking about. We are talking about a basically organization that was created in December 2006. So it's not very old when we are looking about other things like, for example, Boeing that is 100 years old. So, but you have to understand the severity of this company simply because two space giant created them and allowed them to streamline many subcontractors that go into making them. Now, which were these two giant? One of them is Lockheed Martin Space Division, another is Boeing Defense Space and Security Division. Now, to give you a context of what kind of size we are talking about, all these companies, basically Lockheed Martin and Boeing, they are huge, as in freaking huge, and in there they have a division that makes space system. So they are like, okay, let's just get these two division married together. That's how big they are. And what did allow them to do is allowed them to streamline production and management. What does that mean? That simply means, let's say there are customers like a Department of Defense, granddaddy customer, and then we have a small baby customer known as NASA, and they want to figure things out. It's like, hey, we want to take this probe and launch it. Now generally they will do a bidding war. In these two companies will fight. ULA allows them, it's like, okay, we'll see which is more efficient at this point in time. For example, let's say Boeing is pre-booked for this commercial launch, so it will be very difficult for Boeing to have a rocket ready. At that time it's like, Lockheed Martin, I got your back. And other also could happen is like, Lockheed Martin is pre-booked, let's utilize Boeing resources. So that's why it just like simplifies a lot of productions again, and these companies will no longer like just end up bidding against each other. So fundamentally it allows them to simplify a lot of things. And Department of Defense is such a complicated puppy to deal with. It's like, if you can manage this thing, you're gonna be printing money. That's the whole reality of it, because that makes like, its budget is so huge, it makes NASA like, look, chump change, pocket change, here, pocket change, go enjoy. So what kind of tools they are utilizing? Now this is the where you actually understand the size of this thing. Atlas is a whole rocket family. That family is basically child of Lockheed Martin, and that's what got married, put from the Lockheed Martin side. And then we have Delta, that's the from Boeing side. That's how huge they are. They are not like, okay, this one rocket or this one rocket. This rocket family is from my side, this rocket family is my side, these two family are getting together. Now they did this, it worked, it was quite efficient, it simplified a lot of processes and allowed NASA to become much more efficient, because much more rocket can be streamlinedly and launched. So things were awesome, but they realized it's still too much clutter, and SpaceX proved the fact that if you have one good rocket, you can kick ass. So that was the whole point. So they're like, okay, we also need our one kick-ass rocket. So that kick-ass rocket would be Vulcan Centurion rocket. Now Vulcan rocket is already under construction, everything is a go. It's like, it's being made, and I'm pretty sure in few months it would be launched. Now again, it will be a demo launch, not a final launch, but you get the point. Now reality is, at this point in time, if you're not making your rocket reusable, you stuck. If you simply cannot reduce the price no matter what you do. Now again, some people are trying to go through other directions where they're like, let's 3D print the whole rocket, so it's just like raw materials. So human cost goes into the designing and the software aspect, not just like actually going there, running the machines, welding it, doing all that jazz. So they're trying to achieve that, but right now with all the data points we have, it's like, you have to make it reusable, or you have to make it so cheap that using it, throwing it away is like possible. ULA is in neither position, so they have to make their rocket reusable. So how the heck they're gonna make their rocket reusable? They're utilizing what we call smart. Now be mindful, this is an idea at this point in time. It's very sure that they're not gonna test it out in the first launch, or maybe they do, because again, Department of Defense, that means many things are top secret. So the idea with this puppy is like, rocket engines are like basically 65% of the booster cost. Like, where did your money go? Rocket engine consumed 65% of it. So they're like, booster is going up. Now booster, it's basically not at orbital velocity, that's why you need second stage. So booster goes there, detaches. At that point in time is coasting. At this point in time, they're gonna detach the lower section, which has this engines, the important part, and then this part will fall back. It will deploy a inflatable heat shield. Now this not falling that fast nor that heavy, it can manage it. It's like, it's manageable with inflatable heat shield. And during that, like once it reaches the thicker atmosphere, it's gonna deploy a parachute. Now that parachute is more like a parafoil rather than a parachute. It's not supposed to like basically slow down very much, it's supposed to guide them. During that time, a helicopter is gonna grab it mid-air, and then they're gonna bring it back to the center, and they're gonna refurbish it and good to go. Now why do it this way rather than SpaceX approach is like, just make the rocket landable? The problem is, making rocket landable requires fuel. You have limited supply of. So what does that mean? That simply means SpaceX have to compromise certain payload requirements. It's like, hey, if we have to reuse the rocket, the payload requirement goes down. And you can see that is like whenever they are just like, disposable rocket, that sends YOLO amounts of payload, or sends payload much faster. The delta V it can dump into the payload goes higher. So there is a compromise. Now, why SpaceX does not suffer from that is because they overbuilt the rocket. Like 20 tons was rarely a requirement. So they overbuilt it so much that even if they compromise 50% of it, just to require return back to land and not land is just like, who cares? So they have not basically Vulcan is not that kind of bonkers. So they have to utilize, like, this is a good compromise where instead of requiring the fuel to be like saved and then respent, it's like, okay, let's just simplify as quickly as possible. So this is kind of a middle ground between the 100% reusable, like SpaceX booster wise I'm talking, and like at least reuse the important parts of it. So that's their option. So these are the tools that they are deploying at this point in time. Now be mindful, because the company is huge and they have a lot of bright minds behind them. They were also working on a very amazing advanced technology. Now be mindful, this is during Obama administration, is that humanity realized very early on, it's like at this point in time, is like we have to make space propellant depot. Like that's a requirement, that's not optional, we have to make them. And you can see that, heck, what did NASA send to Mars at this point in time? Send a system that figures out to how to make oxygen directly from the Martian system. We learned this the hard way. We have to figure out a way to make fuel on Moon, on Mars, and have the ability to store it them, and then also in basically low Earth orbit, Lagrange points, things of that nature, where we want to have depots. We learned this, like we have to have this, otherwise we have to make ludicrously huge rocket to send ludicrously small payloads. So core technology of that, like it's a good thing, okay, we're gonna have a tank and we're gonna store things. That's not how it works. Like we have to develop a lot of basically secondary technology. Like even fuel pump on Earth, basically I'm talking normal petrol and diesel pump, they are ludicrously complicated technology. It took years and decades, or sometimes even whole century to develop them. So expecting to put them in in space, that's very complicated. So to figure things out, like lay down the foundation on which next versions can build the whole final product, the final system, they developed what we call advanced cryogenic evolved stage. Now this is a quote-unquote test bed. So what was the first requirement? First requirement, when you are talking about a fuel depot, your fuel tank should be the biggest part. Like make the tank as light as possible, as huge as possible. Now we have started to compromise on that recently, simply because we no longer utilize balloon tank. Benefit, far more structurally stable. Side effect, not that efficient. But when you are talking about just propellant, you can take the risk. This puppy not supposed to carry human payloads and all that. Like for testing, they will test it out. So balloon tanks will allow you to carry very huge tank to space for very little mass. So that's good. So first stage does not have to work extra hard. That's the one step. Then these balloon tank will have cryogenic propellants. You want to utilize hydrogen and oxygen for maximum efficiency in space. We have figured it out, and not to mention those engines are surprisingly easy also. And we know this. Like if you want to be in space and if you want to get things done properly, you want to utilize hydrogen and oxygen because it has highest specific impulse. And not to mention engine exhaust is also kind of manageable, more manageable. So they're like, okay, now liquid oxygen, manageable. Liquid hydrogen, not so much. That puppy boils off. Now, if you are putting something like in propellant tank and you let them sit there for a few days, it's gonna boil off. No matter what you do, it's gonna boil off. Not even in days, in hours starts to boil off. So somebody came up with the brilliant idea. We have to pressurize these things. We have to do a lot of things. Why not use the boil off itself as an energy source? You're like, how the heck that will work? Think of this. What you have boil off? Hydrogen. What you have boil off of? Oxygen. You send that into a car engine, and this engine runs on internal combustion engine. Basically, it's literally like a car engine, and it's gonna take the gaseous systems and then gonna burn it off. Now, why would you want to do that? First, it provides you electrical power because you have a generator running. Awesome, that's step one. Step two, because you have exhausts that are hot and pressurized, you're gonna send this exhaust, basically water vapor exhaust, directly into the tank to pressurize it. That's also awesome. And this also allows you to have some extra oomph left for basically providing attitude control and unlimited engine starts. Basically, you can restart the engine as many times as you need. So these are the core technology they have to develop, the bigger version of which will go into the final what we call space depot, so to say. Because right now the SpaceX idea that looks very awesome is like you're just gonna go there, put it back, do this. That's good, but like that's not very what you call independent. That system is very locked, like only Starship to Starship. This system is designed to Starship to whatever you want to do. Or heck, you may end up we may end up sending something ludicrously huge tanks, and all it would be is just like pressurized just so it does not collapse during a launch. And it's just like once it actually goes there, we, Starship, propellant depot version of Starship, which is just like a ferry fuel from basically from ground to low Earth orbit. It keeps up topping it up, and it will have the technology, solar sail, heat shield, all everything required to make sure it does not need too much energy, and it's long term sustainable. So a lot of those sort of tech that we do not think about, and magically we will find out, hey, we figured these things out, because they are figuring it out right now. So they are a serious company that are doing some serious work. However, let's come to the dirty part of it, politics. Now, politics ends up getting direct control over ULA simply because ULA was created out of political necessity. Now, again, the complexity, the hoo-ha that went into it is beyond human understanding. So let's just not talk about that. Now, you have to understand the idea with ULA was like reduce bloat and reduce red tape. It did that. However, it ended up like corporate side, awesome, everything is efficient, smooth, everything. Politics side, it became ludicrously more complicated, because neither of those company can just make decision on their own anymore. Even if they are like, dude, SLS is a bad idea, they cannot just go like, bro, thou shall not make SLS. No, senators will be like, no, you shall make SLS. I don't give a damn it burns another 20 year or $30 billion, who cares. It's just like, you have to do it. So that created a very kind of messy scenario where politics directly ended up controlling them. And another aspect, it because these companies like Department of Defense and basically NASA, these are quote unquote normal kind of client. Basically, they are like Sarkari Nokri in India. It's like these clients is like, once you get them, you're never gonna lose them. For example, SpaceX had to fight. Basically, they had to fight and sue for Air Force to like, dude, allow us to at least bid into your system, because that's how difficult it is to get into that quote unquote club. And once you are in that club, it's like, dude, they're not going to kick you out. So that gives them a false sense of security, and it has started to show off where they are like, if a company is very slow to adapt, very slow to change, because they are in quote unquote club, they will randomly just go poof. For example, one interesting thing happened. This is during Obama administration. Mr. Shelby flat out cancelled the project of fuel depot in space. The reason for that was very simple. If the fuel space in basically fuel depot can be made in space, low Earth orbit, flat out every small rocket becomes a very huge rocket. All you have to do is just send something that can be refueled. The end game over Falcon 9 is like literally 10 times more powerful than this, because think of it this way: you send Falcon 9, second stage does go to orbit. Now at that point in time, it's completely drained of fuel. Little bit of fuel would be there for de-orbiting work if needed. Generally it won't even be there. But imagine this way: if you can refuel it in low Earth orbit, at that point in time, you are on a different level, you are on a different ballgame. If you can 100% refuel basically second stage of Falcon 9 in orbit, full fuel, yeah, it's a completely different ballgame. So that was the whole reality, that was the whole point. It's like, rather than sending huge Saturn 5, send multiple small rockets. So problem with that is that would have cancelled project like SLS. And if SLS would have been cancelled, the building where these things are being made, that is inside this senator's jurisdiction, and the people elected him for one simple reason: make sure we do not lose our job. So it's not like we see kind of basically vilifying of these sort of senators. It's like, these are evil people who are doing evil thing. That's not what they are. They are like simple, like that's their job: make sure we don't lose our job. And he did that. Like at first I was like, he's evil and all that. No, like that's like, think of it this way: like, what if I am the father of a child, and it's like my job is directly dependent on the fact that this company does this thing. Like, I want somebody in the office that's like, no, make sure they do this thing. So I can understand that. So they are in a very kind of messy situation. That's why we call it politics. It's like very messy. Even if canceling SLS might be better for space program, it would be bad for the people who will lose their job. And people who will lose their job, they have elected an individual to make sure that does not happen. However, even over time, like NASA is like, yeah, we cannot keep trusting SLS. So propellant depot project is back on track. So you can politics is a really messy scenario. It's not just like good versus evil. It's like messy. That's all I can talk about. It's just messy. So you cannot talk about space company nowadays simply without talking about competition. Now why is that? Because SpaceX beat ULA's actual record, like how much work you are doing for how much price, and how quickly you are doing it. It's like it's faster and cheaper. So it's like, how the heck that happened? How the heck that happened? The reality is very simple: two different working philosophy. And the early days, like, you can see that people may have this opinion. Is like, let's say SpaceX is doing something for $30 million. Same thing is done by ULA, and they are charging, let's say instead of 30 million, let's say 130 million. People may think, oh, ULA is just gonna digest that 100 million profit. That's not true. Like, the best example of that, we all know how Starships is being constructed. It's like a freaking open garage. Is there just building it, just build it, just figure it out, build it. And I'll provide the video link down below where you can see ULA's factory. Now it looks like a freaking futuristic thing. It looks like a rocket factory. Where it's like, dude, like, that's how Boeing makes their aircraft. It's like a really good clean room. Everything has a structure, everything is fine tuned. Heck, the floor itself would have cost few $1,000,000. And then you have this dude, just put concrete in, man, done, man, no problem, man, no bunny shoot and all that jazz. It's like when ULA was showing that, like, he wanted to see the engine, the YouTuber wanted to see the engine. It's like, yeah, we have a clean room where they're assembling it, you can look at it from, like, that's a clean room with 100 plus people inside them, with huge clean room. Clean rooms are expensive. SpaceX, yeah, just bolt the engine, man, directly bolt the engine, man, on the downstairs. Like, why do you need clean room? Just do it on the open. That's the whole point. That philosophical difference. It's not just like ULA is just burning money. It's like the pipeline they chose is fundamentally inefficient, and SpaceX realized that. It's like everybody is working wrong. That was the biggest brilliant, like, light bulb moment. Dude, you are stupid. It's like this company buys aluminum, big awesome aluminum plates, and then they like send it with a super huge giant awesome machine, and they're gonna, like, mill isogrid pattern. And these company, yeah, we're just gonna buy a, like, a steel roll, and then we're just gonna spool it up. Done. Like, one can be done in open space. Don't even try to Google what kind of price is needed for that kind of milling machine. So that's the reality of it. That philosophical change. It's like, dude, normal individual with normal welding experience can make a rocket ship, and you can just test it, you can double check it, and once you have figured out how the heck this thing works, how much welding you have to put, you can make a rocket, I'm saying a robot after that, to optimize that process. They're moving at lightning speed without burning money. And this company is like, look at that machine. It was like the machines they are using, the clean room they have, the floors they have, that just goddamn the floor. So that philosophy is fundamentally where the money is going. It's not that they are like, we're gonna, like, make a party of $100 million. No, it's like they may be in a scenario where SpaceX may be charging less money, but their profit margin might be higher than what ULA has. So that's the reality of it. And the biggest thing you have to understand, ULA is in kind of a protected bubble where it's like, dude, we have Department of Defense, we have NASA, but even those companies have limitations. Those organizations have limitations. They cannot just go YOLO, keep dropping money in. And Boeing already suffered a loss of confidence from NASA. That is a very big serious thing. So they have to update quickly, or they will have a serious risk of fading away. Basically, one day they will simply lose contract, which already happened. Blue Origin already kicked out a very old prominent company that has been making rocket engines since the Apollo era, because they were not able to keep their cost down. So the race is on. Philosophy is serious. This philosophy will simply not work. It's like, dude, this is too complicated, too goddamn complicated. And this guy is like, yeah, let's just build they're building the factory while building the rocket in it, and like, of course this will be cheaper, of course this will be cheaper. So that's the reality of it. So this was my presentation on ULA. I hope you liked it, learn from it. In that case, please click the like button, share it amongst your friends. That will help me a lot. If you didn't like it, didn't enjoy it, I urge you to press dislike, press it twice to show me extra disappointment. Please leave a comment, because I try to reply to all of them. Subscribe, press the bell icon if you're free. And as always, thanks for watching.